Well, you've made it to part 3 of addition and subtraction equations. We still have the same rules that apply, in particular, getting the variable alone, and in order to do that, you've got to get rid of something that's with the variable, and whatever you do to one side of the equation, you have to do it to the other side as well. Keeps it balanced. If there's two sides of an equation, they must be equal to each other. That's what the equal sign's for. You've got to keep them equal constantly. And this example is a little strange, but if we have negative m plus 3 equals 12, you probably notice that there's not a whole lot different about this, but certainly we haven't had a negative variable yet. And I'm going to have to, before we learn how to solve multiplication equations, you're going to have to trust me on something, and you're going to have to kind of take a logical step as opposed to doing something mathematical for now. Once you learn how to solve multiplication equations, this will become much clearer, I think, and this will be an easier step to take, or you'll at least have a better understanding of it. So the first thing to understand is, what does this negative m actually mean? What's going on there? Well, if you imagine that m might be equal to 5, it doesn't, we're even ignoring what the equation is. Let's pretend m is equal to 5. Well, if m is equal to 5, then negative m must be equal to, I can almost hear you saying it, it must be equal to negative 5. So it just throws the sign in front of that variable, which throws a sign in front of its value as well. It's going to get a little more complicated to a certain extent in this equation, but that's the basic gist of it. If m is equal to positive 5, well, the opposite of positive 5 is negative 5. So the opposite of m must be negative m. And that's kind of the whole premise for this understanding. Now again, once we learn multiplication equations, you'll have a better mathematical understanding of this. But for now, taking that logical step is going to serve you very well for these simple one-step equations. So I need to get my variable alone eventually. I want that m to be all by itself. I've got to start by getting rid of that plus 3 that's with it. So I'm going to take that 3 away. And if I subtract 3 from the left side of the equal sign, I've got to subtract 3 from the right side. 12 minus 3 is 9. My equal sign comes straight down. And this has disappeared. I've made it worth nothing. 3 take away 3 is gone. It's nothing. So I'm done with that. All I've got left over here is negative m. Let's going back to that logic for now. Once you learn multiplication equations, it'll be a little bit easier. But for now, if negative m is positive 9, well, then the opposite of negative m, which is positive m, will be the opposite of positive 9, which is negative 9. Now another thing that's a little strange about this, which we'll also cover with multiplication equations, because I think at this point it'd be too confusing, is that now you realize m is equal to negative 9. Imagine plugging that back into that m. So this is something to think about. That m it's got a negative sign in front of it. So if I have that negative sign next to that m, but instead I replace that m with a negative 9, essentially what I've got is a negative 9. A little strange, but again, we'll talk more about this in multiplication equations. If we've talked about it in class already, that two negatives essentially cancel each other out and they make a positive, then this will make sense to you. 9 plus 3 is 12. So it actually does work. But again, wait till multiplication equations to have a kind of a more solid understanding.